Hello, welcome to chapter 3 for Math 103 at Go Give It Community College. Today we'll be discussing solving equations. All right, so let's continue. Solving equations, what does that mean? It means I don't know, so I'm going to do the work to find out what I need to know. That's essentially the long and short of it. This is, as I said in chapter 2, this is the math that you actually do every day. You're just not used to seeing it on paper and pencil. So objectives for this, how to solve equations and what the different equations look like. So an equation can vary drastically, right? And equation is, the word equation relates to the word equals. If you have an equals in something, it's an equation. So equal sign, right? These horizontal bars stacked on top of each other. If you see that, you have an equation. And it can be an equation without variables, such as, let me draw that. It can be an equation without variables, such as 9 plus 3 equals 12. It can be an equation with one variable, such as this with the x. It can be a variable equation with different variables. Y is y squared, it's x's and y's. And honestly, it can be an equation without any math problem to do. Z equals 2 is an equation because it has an equal sign in it. And as we talked about before, variables means a variable means it's variable, right? the word is self-defining. So if I have a letter, any number can be placed in that letter, but not every number is the correct answer depending on the equation. So we have x plus 8 equals 13. The x is the unknown, the x is the variable. You can plug any number you want into x, but that won't make the equation true. So for this example here, we have 5 plus 8 equals 13. That's a true equation because 5 plus 8 is in fact equal to 13. X can be any number. You can put 7 in there, but that results in a false equation, an incorrect answer. 7 plus 8 does not equal 13. That's wrong. You can still technically replace x with 7 if you want to, but you're getting a false answer. So you're not doing anything useful, right? The true answer to the equation is what we call the solution to the equation, the solution to the problem. So you can ask questions. Again, this is the math you do every day is what we're talking about here, but we'll put it down on pencil and paper. I can ask you, is -2 a solution of the equation 2x plus 5 equals x squared minus 3? To solve that, I need to take my equation, and every time I have a variable, in this case x, I replace that variable with -2. So 2 times -2 is -4. Okay, -4 plus 5 is equal to 1. Good. So this left hand of the equation by itself is equal to 1. And then the right hand of the equation, substitute -2 for x, square that, 4 minus 1 is 3. They are in fact equal. -2 is a solution to that problem. What we did is we took one big equation, we solved one side of it, solved the other side of it, and then came back together at the end to see if the solution worked. That's how we're going to be solving more or less all these equations. You need both sides of an equal sign to say the same thing for it to be true, for you to have found a solution. Once you hit that point, you're good. And that's what that does there. Cool. And again, you can continue this trend. As we've been doing for the lectures up to this point, at some point, I'm going to ask you to pause the video, solve it for yourself, and then play it again to check your work. If you are good with this stuff, you don't need the practice. Excellent. Do the assignment, get it to me, all good. If you do need the practice, math is best learned by doing. The more math you do, the more you're going to figure this out, the more you're going to be able to utilize the shortcuts and not get yourself lost. As you can see, -4 is not a solution. It's an incorrect solution. It's a false statement. It's not the answer. Well, you do have the answer. The answer is that -4 is not the answer or not the solution. So that's how you answer questions when I give you an option. But how can you find the option by yourself? Again, solving equations means getting both sides equal sign is mean the same thing, or the way I explain this is getting all your letters on one side and all your numbers on the other side. This form up top here, variable equals constant, means whatever equation you have, solve it until you have x equals, or y equals, or a equals, because that is a solution. If I tell you x equals 5, and I ask you what x is, you're probably going to tell me 5, right? Because I told you x equals 5, therefore x equals 5. So whatever equation you have, like this bottom one down here, x plus 2 equals 9, we notice that we have a letter on the left, a number on the right, and a number on the left. So I need to get those numbers over to the right, so that way I have all variables on one side of the equal sign and all numbers on the other side of the equal sign. So let's go over some examples here and work that process out. The way you work that process out is by essentially doing something to one side and the other side of the equal sign. If you, and we talked about this last chapter with fractions and ratios and stuff like that. An equal sign is two opposite things I'm saying are the same. I'm sorry, not two opposite things. Okay, let me rephrase that. Two sides that are the same thing, in fact. That's what equal sign says. The left of the equal sign and the right of the equal sign are equal. So if I do something to the left side of the equal sign, I do the same thing to the right side of the equal sign, I'm not doing anything new to the entire solution, to the entire equation. If you have twice as many M&Ms that I do, if I have 10 M&Ms, you have 20 M&Ms, and then I give myself 4 M&Ms and I give you 4 M&Ms, you still have the same amount of M&Ms more than I do, right? That's what's going on here. If you do the same thing to both sides, you're not messing up anything part of the equation. So we have the equation here, x plus 2 equals 9. I can go ahead and add 4 to both sides of that equation, and I get x plus 6 equals 13. It's still the same problem. The numbers are different, but still fundamentally the same problem, because x equals 7 is a solution to the top one, x plus 2 equals 9, and the bottom one, x plus 6 equals 13. It's still the same problem. That's the key factor to solving variable equations, is as long as you do the same thing to both sides, you can do whatever you want because you're doing the same thing to both sides. That's what, as it says here, this calls the addition property of equations. It's just whatever you do to one side, do the other side, and you're safe. So let's go to an example. Here we go. All right, so x minus 4 equals 2. I want to solve for x. How do I solve for x? I solve for x by getting it to where I have all my variables on one side and then all my numbers on the other side, and just an equal sign between them. Right now, as you can tell, I have an x on the left, but I have a number on the left and the right. I don't want that. So I gotta move things around. We move things around via the, as I said before, additive property of equations. Meaning, I need to get this, oh, there you go. I need to get this 4 to the other side of the equal sign. How do I do that? Well, let's go back to our understanding of mathematical operators and how they work, right? When we look back and we talk about number lines in chapter 1, we said that moving to the right on a number line, let me draw a number line here. Wow, this is a really poorly drawn number line. There we go. Let's say that's a 0 and that goes off infinitely in both directions. Cool. If we move to the right of the number line, we are growing. If we move to the left of the number line, we are shrinking, or positive and negative, right? So positive and negative are opposites of each other. Positive is to the right, negative is to the left. Positive is up the number line, negative is down the number line. Okay? Positive and negative are opposites of each other. So if I want to move something to the other side of an equation, I need to do its opposite. if I want this -4 here, if I want this -4 here to move, I need to do the opposite of -4 to it. What is the opposite of -4? The opposite of -4, the opposite of -4 is +4, right? So I need to put +4 next to the -4, and that will do the opposite. But whenever I do something to one side of an equal sign, I need to do the same thing to the other side of the equal sign, like this. See, I'm adding 4 to both sides. So when I do my math, I say x, x is still x, and I have -4 and +4. Well, -4 plus 4 equals 0, right? If I start at -4 and I add 4, I get 0. So I can rewrite the initial left side of the equation as x plus 0. Adding 0 to anything is essentially redundant, because if I take something, don't do anything to it, I still have the same thing. So I can just write that as x. Now I can solve the right hand of the equation sign. 2 plus 4 equals 6. So run that down here. Equals 6. And now I have an equation where I have all the letters on one side, and I have all the numbers on the other side. I've transformed this equation into one with variable equals constant, or letters equal number. Letter equals number. Once I have hit that, I have solved my equation. X equals 6. If I plug this back into the original, I would say 6 minus 4 equals 2. Is that true? Yes. It's a correct solution. Is this problem solved? And I did that by doing the same thing to both sides of the equation and trying to essentially move numbers around, or eventually move letters around, by utilizing their opposite. And clear this. It's going to walk through that in their terms. There you go. It's a true equation. So a shorthand way. So I'm going to suggest you pause the video, do this on your own. When you come back, I'll show you the shorthand wording for this process. All right. So the shorthand wording for doing this is, remember, I have a 15 that I need to move because it's with a letter. I don't want that. So what I suggest to people is, this is the way I do it. Any way that you want to do this process that makes sense to you, do it that way. The way I do this process is I write what I'm doing in like little numbers, essentially, around the thing. So I have x plus 15 equals 23. That 15 I don't like. I want to move that 15 to the other side. So I subtract, and this is what I write on the piece of paper. I subtract the 15 from both sides. When I subtract 15 from the left side, they cancel, so I draw a little line through them. Sometimes I make little exploding sounds, bang, smash, something like that, just to animate the process. In the in-person classroom, I always like to do exploding sounds. But what I'm doing there, when I draw that line through, is I'm saying this doesn't matter because this equals 0. Because this whole process, let's do this in purpley. That looks fun. So this dude here is 50. Oops, what is that? What is that shape? Oh my gosh, come here, eraser. There we go. 15, positive 15 minus 15. And that whole thing equals 0. So essentially, I've rewritten that as x equals 0. The x is irrelevant, so I just write this out as x. And then on the right side of the equal sign, I have 23 minus 15. Well, I can solve that. That equals what? 8, right? Yeah, 8. So I use that in the color, whatever. So this side here I solve. This side here I cancel, so I can skip over those steps once I'm good enough at it, mind you, to result in x equals 8, which is what we did. There you go. Again, the book is going this line by line by line. I'm going to highly encourage you go line by line by line until you're good enough at solving equations where you can figure out your own trick to it. Another trick people tend to do, I'm going to back up here, to solve these, and again, whatever works best for you, is to put them on the outside. Minus 15 there, minus 15 there, like that. And then they'll solve it out by canceling this way to say x equals 8. Whatever organization works best for you, do that and practice it that way. So we said before that the opposite of addition is subtraction. The opposite of multiplication is division. So if you have numbers that are multiplying together, such as this 2x equals 6, you solve them by following the same principle, but using a different rule. Again, instead of addition and subtraction, you have multiplication and division. And there's an opposite for everything. Exponents have an opposite too, but that's a different math class entirely. Because anything you do to one side and you do it the same to the other side, you've done the same thing. If I have 5 marbles and you have 10 marbles, and we multiply the amount of marbles we have each by 3, you still have twice the marbles I have, right? If I start with 5 marbles and I get 3 times the marbles, I have 15 marbles. If you start with 10 marbles, you get 3 times the marbles, you have 30. You still have double my marbles, right? The ratio is stood, but the numbers are different. The important part though is that the ratio is stood. So how do we do this? So I have an equation here, 3 over 4 times z equals 9. I want to know what z is. Well, again, we have a situation where I want all letters on one side and all numbers on the other side. And I will also say at this point that it doesn't matter which is which. If the letters are on the left or the numbers are on the left, that doesn't matter. I usually say x equals number because that's how you say it, right? X equals 7 or something like that. But it doesn't matter. And honestly, if this equation is reversed or it said 9 equals 3/4 z, I'd keep the z on the right. Anyways, so how do you solve this? Well, I have 3/4 and it's multiplied by z there. So what's the opposite of multiplication? Division is the opposite of multiplication. So I essentially need to divide this 3/4 by 3/4, right? Does that make sense? Well, yeah. If I divide 3/4 by 3/4, anything over itself is equal to 1, and anything times 1 is equal to itself, right? So therefore, if you, and anything times itself is equal to, anything times 1 is equal to itself, and that's irrelevant to write, so you don't write it, right? So if I take 3/4 and divide by 3/4, these cancel, just giving me a z. But the fun part is 9 divided by 3 over 4, that's really ugly looking, right? So the fun part about multiplication and fractions is, sure, dividing by the fraction is in and of itself a way to get rid of it. But another way, the opposite of a fraction is its reciprocal. Remember that from chapter 2? It was reciprocal. So 3 over 2, its reciprocal is 2 over 3. Because when you multiply those out together, you get the same thing. Multiply straight across, x equals 6, which equals 1. So you can cancel out fractions by multiplying by the reciprocal. Or if I say I have 3 over 4 times z, I can multiply that both sides by 4 over 3. Again, what is my opposite? I use my opposite to get rid of it, right? Because 3 times 4 is, what's that, 12? And 4 times 3 is 12. So I have 12 over 12 times z, which is, 12 over 12 is 1. 1 times z, which is just z. So I've successfully blown this up by multiplying by the reciprocal. Or, as we'll get to later, multiplying by the reciprocal and dividing the same thing, right? So all I have left is 9 times 4 over 3. And we didn't really get this into too much, but I wish the book did a little better job with this. Any number is in and of itself that number over 1. So the number 9 is the equivalent to saying the number 9 divided by 1. Because anything divided by 1 is itself, in the same way anything multiplied by 1 is itself. So this 9 is the same thing as saying 9 over 1, which gives me fractions to multiply straight across. So what's that, 27 over 3? 27 over 3, and then whatever math that turns into, like some number. That's how you solve it. 27 over 3, that'd be 9, right? 9, 18, 27, yeah, so that equals 9. So Z equals 9. So that is the process for solving these. And again, the takeaway I want you to do from all this is whatever you do to one side, do the other. And if you want to solve problems, 12, whoops. Whoopsie. My head math wasn't very good. Whatever you solve, you do the same thing to both sides. So see here, we did the multiple, gosh, I'm losing my words here. The reciprocal, there we go. The reciprocal of 3 over 4 is 4 over 3. So we can, it's because I did 36 over 3, not 27 over 3. That was the problem. Yeah. Okay. I know I did wrong. Sorry about that. So 4 over 3 times 3 over 4 cancels each other out. Kaboom, smash, right? And then 4/3 times 9 gives you 12. Or I said 36 over 3. I just screwed up my math. But that is solving these problems. Multiplication and division both work the same way. Here we have 3/4 x. Again, this is a good example. 3x over 4 is the same thing as saying 3 over 4 times x. These are the same sentence. So if you rewrite the equation as 3 over 4 times x equals -9, then it's probably kind of obvious what you need to do, which is multiply both sides by 4 over 3. These cancel then, kaboom, smash, bang. So you get 9x equals -9 times 4/3, which is x equals -12, right? We just did this. Pretend that x is an x, there we go. So we take our numbers, we figure out what needs to be done with them. Do I have addition? Do I have subtraction? Do I have multiplication? Do I have division? Whatever is in the equation, figure out its opposite and apply that to both sides. You do that systematically, you eventually break the equation down into its basic form of letter equals number, variable equals constant. Once you hit the space where you're at letter equals number, you solve the equation. So let's apply this in various ways. Most common application of this idea is percentage. Percentage follows the equation percentage times base equals amount. So what do I mean by that? Well, 20% of what number is 30? I can take this information and I can say, all right, I know 20% is a percent because there's a percent sign there, right? And 20%, in case you were unaware, is equal to 0.2 because percent is out of 100, 20 out of 100 is the same thing as saying 0.2. And then our amount is 30 because that's the end result. And we want to know what number or what base comes out of that to equal what we need. So we solve this by plugging in the equation. And now we notice I have numbers times letters on the left and just numbers on the right. I don't like that. I need to solve that out. Well, the opposite of multiplication is division. So I divide both sides by 0.2, plug 30 divided by 0.2 in my calculator, honestly, to get out your answer. 20% of 150 is 30. My base, my original number is 150. 30 is my solution, or my end number. And there you go. Here's some shorthand fractions. I don't know anyone that really cares about this, but there you go, in case you need to do shorthand for stuff. Interest rate equations follow the same basic concept where I give you a bunch of information, and if you can plug it in to get to your solution. Percentage mixtures work the same way. Q equals AR, where Q is a quantity of a substance, A is the amount, and R is a percent concentration. Cranberry juice, I guess, is what they chose there for all you people drinking all that cranberry juice. Yeah. Again, these equations, I'm going to highly suggest you write these down for your homework, right? Percentage equation, P times B equals A. Interest rate, I equals PRT. I is your invest simple interest, P is your principal, R is your interest rate, T is your time. And these are numbers that would be given to you over the course of solving the problem. And percentage mixture, Q equals AR. And know what these letters mean, right? Each of these is variables. So any one of those letters can become a number based on the question, which we'll get to when we do the actual questions up here. So, all right, so here's an example for us. The data in this table below show the number of households in millions that downloaded music files for a 3-month period in recent year. The book's kind of old, right? In April, 14.5 million people downloaded. In May, 12.7 million. And in June, 10.4 million. Apparently, people stopped downloading music as summer started. For a 3-month period, what percentage of files are downloaded in May? Round to the nearest percentage. So given these three numbers, what percent of this total is just May? So let's try to solve that problem. Well, we know percentage, right? Because we see the question asking percentage, so I need this equation. So I start by writing P times B equals A. That's the top of what I'm doing. P times B equals A, right? P is my percentage, B is my base, A is my answer, or the end product, right? Then I need to look at the question and figure out exactly what I'm trying to solve. I'm trying to solve the percent of the files downloaded in May. May is 12.7, but it's of that 3-month period. So how much stuff is downloaded? What percentage of that is 12.7? So in total, I can add those numbers up and see that over that 3-month period, 37.6 million files are downloaded. So is 37.6 million my B or my A? This was 12.7. What letters correlate with what numbers? That's a big question at this point, right? So I know from looking at the numbers I have no percentages given to me. In fact, it asks me for a percentage. So my unknown is P. It's going to be terrible. N W N. That looks like the word unknown, kind of, right? Yeah. It looks like an R, not a K. But my unknown is P. So then these two numbers have to either be a B or an A, which is which? Which is my base, and which is my amount? It's hard to tell, right? So your base is what you start with, and your amount is what you end up with, or your amount is sort of the answer to the question, right? So which of these two, another way to think about it usually is the base tends to be the bigger number and the amount tends to be the smaller number, because you start, but that's only true if the percentage is less than 100, so it's not a good way to run it always, right? I will tell you that my base amount is my 37.6, because that's another way to think about it is your total, or your whole, the amount that you have to start with is your base, right? I know I sold 37.6 million music downloads, right? My amount at the end here is 12.7 because that's the amount I care about for the question. My base is, regardless of the question, the amount is what I care about. So some percentage times 37.6 equals some amount of 12.7. Oh my gosh, I'm just going to delete that and move forward in the question. My handwriting's getting terrible. There you go. So how do you solve this? Well, I notice the percentage is multiplied by the base. What's the opposite of multiplication? Division. So I need to divide out the 37.6 to get my result. And what they're doing here, which they didn't show you, is they're dividing both sides by 37.6. And when they do that, they are canceling out the 37.6 on the left side, giving you just a letter, and then a math equation on the right in which to solve. When you solve that math equation, you get about 34%. Excellent. Good news. Uniform motion, another example problem. D equals RT, distance equals rate times time. This, of course, you can adjust this all around if you want. But, miles per hour is distance divided by time, stuff like that. But this is another example of using this, solving equations and using variables and constants, letters and numbers to answer questions you might have. Your car travels 50 miles per hour for 3 hours. How far did you travel, right? So in your head, you probably do 50 times 3 to get there. But why do you do that? Well, you do that because the uniform motion equation is distance equals rate times time. If I know my rate of 50, I know my time of 3 hours, I multiply those together because the equation tells me to. Right? Again, you do this math all the time. This is what it looks like on paper. That's the thing I'm trying to stress here. This one, I'm going to pause and you look at it, read it, understand it. If you've got a problem, feel free to email me a comment on the YouTube video. I'll do my best to try to explain stuff in more detail. Same here. Read these, look at that graphic, make sure things make sense. Right? This is the life we live. We all know the boat moves faster with the current than against the current. But funny enough, right, there's a math equation to verify that. And knowing how that math equation works allows you to do more complicated things that don't have, those obvious real life solutions to them. So, 2 cyclists start at the same time at opposite ends of an 80-mile course. One cyclist is traveling 18 miles per hour. The second cyclist is traveling at 14 miles per hour. How long after they begin cycling will they meet? This is like a classic IQ test problem, right? Or the SAT test problem. Two driving towards each other, when do they meet? Well, you could overly complicate this by trying to organize each other's times, or you could simplify the process. Because if they're traveling towards each other, they have a speed that defines both of them. So what this is wanting you to do is consider that combined speed. If one's moving 18 and the other's moving 14, they're moving towards each other, that's the same thing as saying one's not moving, the other one's moving at 32, right? Those are the same situation. We're just going to redefine it so the math is easier. If I'm driving 55 miles per hour on the highway, you pass me going 60, you're driving 5 miles an hour faster than me. And it would look no different if I was stopped and you were driving at 5 miles per hour. Relative to each other, it's the same thing. So if you can take these questions and sort of think about them before you do them, you can realize that a lot of these complicated looking math problems have rather simple solutions if you stop and think about it, which again is kind of the point of why these things are like IQ tests and stuff like that. So instead of having the bicyclists travel towards each other, which is what's actually happening, I can calculate based on one bicyclist not moving and the other one going at 32 miles per hour. And when I do that, my math becomes very, very easy. And I know it's here, I have 32 times t, that's multiplication. What's the opposite of multiplication? Division. So if I divide both sides by 32, because if I do the one side, I do the other side. If I divide both sides by 32, I blow up the 32s, resulting in number times letter, or constant times variable. And it doesn't matter which side of the equation side the t is, as long as there's no numbers with it. It takes 2.5 hours for the cyclists to meet each other. Sweet. General equations part 2. This is expanding onto essentially more complicated things. So I have to move multiple letters and numbers around to solve the problem. And this problem here is actually where part 2 starts. So I'm going to stop the video here. It continues on with part 2. And again, I wish you luck. However, before this video is over, I do highly suggest anytime there is a question in this lecture series, pause the video and try to solve it on your own if you can. If you look at this like, oh, this is easy, you probably don't need the rest of the video series, right? If you look at this and you're confused, good thing you're watching this video series. That's what I have. Take care.